All right, so 10-4, polar coordinates and their graphs. So first off, let's just talk about what they look like. So um, we'll do polar coordinates and how they look like in terms of an angle. All right, so I'm just going to label a couple things really quick. So this is R, this is our directed distance. So directed distance is R. This is theta, which we call our directed angle. We'll call the x-axis our polar axis. And then if we happen to have a point, let's call it P, we're going to label it r theta. And right now we'll kind of put a couple little definitions for this thing. This is normally graphed on polar graphs. So not like what you're used to seeing in terms of x and y, but usually done in something that we consider polar graphs. I wonder if I can show you real quick. This wasn't something I planned on doing, but let's see. Let me go to Desmos real quick. I think I can change the setting to polar. Yeah, right here. So this is what polar graphs look like. So you'll notice, let me make this projector mode. Notice how like they have the numbers 1 through 5 are left and right. Like you can go 1, 2, 3, 4, 5 based on every radius that you see. So there's like a really small circle that's 1. The next circle after that is 2. The next one is 3. The next one is 4. Then 5, 6, 7, 8, 9, 10. So you can see the distances are measured in radii of a circle. Okay. And then they also label angles, right? So they have like a 30 degree, 60 degree, a 90 degree. Now there is a 45 and a 75 and a 15 and all that other stuff in between. So if I were to tell you that I had a polar coordinate of 2 comma pi over 6, okay, then it would be somewhere, where is that? 1, 2. So I don't know if you can see where my mark is, but that would be about 2 pi over 6 right here. If there was a coordinate like 3 comma 5 pi over 6, then that would be right here. That would be 3 comma 5 pi. So you draw the line that would create that arrow that points to that point. Okay, because the coordinates r comma theta, r is a distance. So they're saying draw a line that's this long at this angle. That's what r theta means. Okay, and we're going to get to that. Like I said, I'm kind of jumping ahead of myself here, but we are going to get to that. So anyway, let's go with some of these pieces here. So first off, so the origin, this is called the pole. As in the North Pole, kind of, okay? So it's called the pole. Or some people will call it the origin. Okay, and it's represented by the following point, 0 comma theta. It doesn't matter what the angle is. If it has a radial distance of 0, that means it's just a point. Okay, so 0 comma pi over 6, 0 comma pi, it doesn't matter. The directed distance is 0, so it's just going to be a point. Okay, so that's called the pole. Now r is the directed distance. So r is the directed distance. And as you guys saw, it's based on circles, right? Those polar graphs are all circular. So whatever the R value is, it represents the radius, right? It represents like a radius, a radii. So it's the distance from the origin or the pole to the point. Okay, so theta is the directed angle. I forgot to highlight this for you guys here. So theta is the directed angle, okay, and we tend to do this counterclockwise. And it's kind of funny, we were actually talking about this last time in one of our meetings with all the math teachers. We're wondering how much longer kids are going to understand that, counterclockwise. Because how many clocks do you see that actually have a clockwise or counterclockwise motion, right? Everything's digital now. Most of the stuff people use is digital. So who knows, we may have to teach them what a clock used to look like and how they worked and why we call it clockwise and counterclockwise. But theta is the directed angle. It's usually done counterclockwise from the polar axis so in other words, the x-axis to segment OP. Okay, so you basically go to the terminal side, right? Remember, I don't know if you guys remember doing that, terminal angles. So to figure out where it terminated, right? So we would go to the line that created the end of the angle, so we call it terminal angle. So the same thing with this right here. Theta is a directed angle, counterclockwise, from the polar axis to segment OP. All right, so nothing, groundbreaking. It's just definitions. Now, there's a lot of definitions today, so that's why I kind of introduced this to you guys today, the main definitions. Then we do some work on it tomorrow. But let's talk about coordinate conversion. So how do we convert these things? So since I told you guys that our polar graphs look like circles, so we're going to use circle formula. So using the circle equation of x squared plus y squared equals r squared, okay, and knowing that sine of theta is equal to y, oh no, that's right, y over r, and cosine of theta is equal to x over r. We find that x is equal to r cosine theta. So notice we can replace the letter x with an r and something with theta. So now we have polar coordinates in a sense, right? R thetas. So we get x equals r cosine theta, y equals r sine theta, and notice the tangent of theta, they're just going to leave it as y over x, but you could always write it as sine theta over cosine theta too, okay? But this is kind of like the important thing here that they mentioned, okay? The x definition and the y definition. Okay, so now you know that you can rewrite a lot of this information based on your x and y values being solved for x and y, so you get r cosine theta, r sine theta. Okay, so that's just one thing here. Now, aside from that, that's actually a theorem, but aside from that, let's kind of go over some real quick examples. So, by the way, don't forget this, okay? I know I didn't highlight it at first, but we'll just kind of leave it there. But don't forget about that. That's actually a nice way to convert backwards using this definition there. Okay, so it just kind of depends on what they want us to use. But right now we'll do some examples so you can see how we use them. So we'll start with example 1. So we're going to convert from polar to rectangular. Convert from polar to rectangular. So here's the first one. If r theta is 2 comma pi. In other words, r is 2 and pi, theta is pi. So they want us to convert this into a rectangular point. So use your definitions. X is equal to r cosine theta and y is equal to r sine theta. So r is 2 cosine of pi, and for y we have 2 sine of pi. Well, cosine of pi is -1, so x is -2. And sine of pi is 0, so y would be 0, so your rectangular point would be -2, 0. Which makes sense. If I could kind of draw this for you just so you can see. But it makes perfect sense because, let's get a graph here. Something small, nothing major. The point -2, 0 is right there. Okay, that's rectangular wise. But if I were to start from this angle here and stop at that point, how much of an angle is that? That's 180, which is pi, right? And what would the r value be for this line that I would have to create? It would have to be 2 units long, right? So 2 comma theta is the same as -2 comma 0, because -2 comma 0 is 2 units away from the origin, right? Laying flat on the x-axis, negative x-axis to be exact. And the polar point, it says it's 2 units long at an angle of pi, right? So you could see right there, they're exactly the same point. It's just a different way to write it. Okay, so let's look at part B. So part B, I'm going to give you r comma theta, radical 3 comma pi over 6. And I'm going to give you a minute to solve this, okay? I'm going to pause it. All right, so we gave you guys a little bit of time. Hopefully you got this right. Anybody want to tell me what you got? Did anybody get the x value?
I got 3/2.
3/2 is correct. Anybody get the y value? Square root 3 over 2. So yeah, so your x would be 3/2. Your y would be radical 3/2. Now let's just go ahead and do this. This is r cosine, sorry. Cosine theta, and y is equal to r sine theta. So we'll kind of work on both sides at the same time. So my r value is radical 3 and my theta is pi over 6. So x is equal to radical 3 cosine of pi over 6, and y is radical 3 sine of pi over 6. Now, cosine of 30 degrees is radical 3/2, so this would be radical 3 times radical 3/2. So this is going to simplify to 3/2. On the y side, sine of pi over 6, or 30 degrees, is half. So we get y equals to radical 3 times half. So y is radical 3/2. So your rectangular point would be a 3/2, comma, radical 3/2. Now, of course, if you were to graph this, right, if you wanted to show it, now this is a little bit harder to do if I'm not doing a, I don't think I have that option. Let me see. No, they don't give me an option to do a polar graph here. It'd be kind of nice if they did. So let's see. So if we were to graph it, radical 3 comma pi over 6, that's a 30-degree angle at rad 3. Now rad 3 is, what is that, 1.7 something? Let me double check that, but I think that might be right. Should be about 2 units. Now for something like this, you're probably going to have to use a ruler, but I'm just going to kind of guesstimate. But let me see, radical 3, 1.732. So, and then at a 30-degree angle. So this is just going to be a guesstimate, okay? So here's my polar axis. We'll say 30 degrees is about there. And actually has to be a little shorter because it can't lie at 2. So that right there is about 30 degrees, almost 2 units. Notice if you get that little angle that I did and lay down that arrow, it's not supposed to be touching 2. It might be a little short, so 1.73. And the angle is about 30 degrees, right? So this angle here is about 30 degrees, and the directed distance is supposed to be like 1.732. Okay, that's going to be your R value. Okay? Now, if we did it right, then that means that the point that I'm touching right there is defined as 3/2, comma, radical 3 over 2. Okay, those are kind of hard to convince people because they're not obvious. It's not like the first graph where you obviously saw -2, 0, and then you saw, oh, a distance of 2 at an angle of 180. Okay, makes sense. These are a little tougher, especially when you don't have the Desmos or something like that shows it to you, right? So anyway, that's something that we have for that. So that's conversion. Now let's convert the other way. Let's convert from rectangular to polar. So example number 2. Convert from rectangular to polar. All right, so for part A, I'm going to write for quadrant 2, xy is equal to -1, comma 1. Okay, so they mentioned the quadrant, and it's kind of important right now when we start doing the work, but notice how they gave me an xy, and from the 3 equations we had, they gave we did x equals r cosine theta, y equals r sine theta, and tangent theta equals y over x, right? Tangent of theta is used a lot to do conversion from rectangular to polar because it contains the x and the y that normally you're given. So tangent of theta would be 1 over -1. So that means tangent of theta is -1, which makes sense because they say it's in quadrant 2, so tangent is negative. But it's helpful for my angle because if tangent of theta is -1, my angle has to be a 45 degree, but in quadrant 2. So that would be what pi over 4? It's some number pi over 4. 3 pi over 4, yeah. So this would be 3 pi over 4. That's why they mentioned the quadrant, okay? Because you can't just write pi over 4 and expect it to be in the same location as the point, okay? So the angle would have to be 3 pi over 4. Now, after that, all you have to do is find your r value, and you can do that with any of the two equations of x or y. Okay, it's up to you however you want to do it. Now, the easiest way to do it is by using this. Whoops, wrong thing. X squared plus y squared equals r squared, right? Because you could always use the circle equation. We know our x and y, right? We know it's negative 1 squared plus 1 squared equals r squared. So that's 2, or r would be a radical 2. So now I have my r theta. So all I have to do is just plug in r and theta into my coordinate. So radical 2, comma, 3 pi over 4. And that would be my polar coordinate represented by the point negative 1, comma 1. So again, nothing like super difficult or anything like that. You know, it just takes a little bit of time of calculation. So let me give you a little bit of time to try this one. Okay, I'll give you a minute. Do b equal to, if they give you x, y, 0, 2. Anybody have an answer for x? A 2? Yeah, it would be a 2. Anybody have an answer for theta? Pi over 2. Okay, it's straight up, right? 0, 2 is on the y-axis, so it makes sense that the angle should be 90 degrees, right? 0, 2 is on the y-axis, so it makes sense that it would be 90 degrees. Let me put that right here. 0, 2 is found on the y-axis, so theta would have to be pi over 2. Right? Now, knowing that, you could use the x squared plus y squared equals r squared formula to do this. Or, again, you can just think about the fact that it's 0, 2. It makes it 2 units exactly from the origin. So that means your r would be 2. But if you don't see it like that, you could use this here. So 0 squared plus 2 squared equals r squared, which implies that r has to equal to 2, right? Because that's just r squared equals 4. So you would know that 2 comma pi over 2 would be your rectangular coordinate. So sometimes it's a little bit easier based on how much you think about the point. You might be able to get it done without doing any formulas. Especially the ones that lie on the actual axes. Those are a lot easier. If you know something's a perfect 45-degree angle based on the point, like 1, 1, 2, 2, 3, 3, or something like that, it might be easy to figure out angles. Okay, and then from there just figure out your r value based on distance. But yeah, always kind of think about what you know and what you know about the graphs, and is there any shortcut you can take so that you could actually get the answer you want. Okay, so here's the last example for you guys, and this doesn't really have a lot of work to do. It's more you kind of thinking about it. Describe the graph and the last one's a little tricky, I'll tell you that, of each of each polar equation. Okay, so we're going to start off easy. Now you might say that doesn't look that easy, but there's the first function, r equals 2. Anybody think you know what this looks like? Like, you can describe it in a rectangular form. It says r equals 2. What's the theta? Do they mention theta? No, right? So theta can be anything. It doesn't matter what theta is. What matters is r has to be 2. So what shape is that? That's a circle, right? They don't mention anything about the angle. That means theta can be anything. But the r value is always going to be 2. The distance from the origin will always be 2. So if you plot every single point that's 2 units away from the origin at every single possible angle, what you're going to end up getting is something circular, right? So this is going to be a circle. All right. So this is a circle. With equation x squared plus y squared equals 4. All right. B. Theta equals pi over 3. Still easy, but I don't think it's as easy as r equals something. Anybody give me a guess on what kind of graph this would be? Huh? It would be a line. Because notice they don't mention anything about its length, right? They just say whatever it is, it's at an angle of pi over 3 at all times. Okay? So how do we figure out the formula for it? Well, we'll start with this. As you said, it's a line, so it'd be great if I can write y equals mx plus b, right? Now, tangent of theta is given, right? Tangent of pi over 3, so let me write this down, is equal to y over x. And tangent of 60 degrees is radical 3, right? So that would be radical 3 equals y over x. So if I solve for y, I get the following. Radical 3x. And that's my function. That's a line that crosses through the origin with the slope of radical 3 over 1. All right, so this next one, it is easy, but it's tricky. Okay? It is tricky, so let me write this down for you. So think about this. Okay, r equals to secant of theta. What does your gut tell you to do? What do you feel like doing to something like this besides erasing it? Making it cosine. Okay, that's what my gut says. It's just rewrite it to something that I feel more comfortable with. Okay, now what do you feel like doing? All right, move the cosine over. R cosine theta equals 1. What's r cosine theta? X. X equals 1. So there's my equation. What kind of graph is that? Going what? Vertically. Yeah, it's a vertical line at x equal to 1. All right, so no homework. I'm just going to leave you guys off at this. I mean, you can see it's not like insanely difficult stuff. Very common. I mean, we're just dealing with different types of coordinates right now, okay? And different types of, or I guess the same graphs we're used to with different looking equations, okay? So we'll stop here.